Here we go. This is my energy problem, and we're going to solve it together right now. I've gone through it once, and I've underlined all the important numbers that we're going to be using. So let's go ahead and read it. There are two people who each are 60 kilograms, are on a roller coaster that has a mass of 150 kilograms. The roller coaster car is at the top of a hill that is 95 meters up, point A, right here. At that instant, it is traveling at 25 meters per second, while at the top of the loop-de-loop, point B, right here, one of the riders lets go of his bag, which weighs 5 kilograms. The person loses their bag and continues on the ride. What is the velocity of the car at the other side of the roller coaster, which is 45 meters high? Point C. The gravity is equal to 10 meters per second squared, and I've taken the time to draw out the information here, and I've included some of the numbers. I've also included the essential equations that we're going to be using, which all stem from the law of conservation of energy, which I wrote out right here, which states that all initial energy, the sum of the initial energy is equal to the sum of the final energy. I've taken that a step further, and I've broken it down into gravitational potential energy and kinetic energy, which are present at both A and C, which are the 2 points that we're going to be solving for. So the one thing that's kind of changing and shifting throughout this problem is the mass. So we're going to start with that. So we know that there's two people who each weigh 60 kilograms, and that the roller coaster car itself equals 150. This equals 270 kilograms, which equals our initial mass. But we must remember that at point B right here, somebody drops their bag, which changes it, making it the initial mass and the final mass, they're going to be different. So we're going to subtract 5, and that's going to give us our final mass, which is 265. So with this and the information given in the text, we can slowly start to fill in our equation. I've done this on this page right here. And from here, I've also simplified it one more steps to try and streamline everything. So we're going to just start to solve this with our calculators. So 340,875 minus 119250 from each side. I messed up right there, but I'm going to correct it. There we go. And that's going to equal 221625 is equal to 132.5 final velocity squared. And our final velocity is what we're solving for. That's why it's left as the variable. So we're going to divide by 132.5. So there we go. 32.5. That's 1,672.6. About 6.4 is equal to the final velocity squared. But we want just our final velocity, not our squared value. So we're going to take the square root. And that's going to give us our final velocity, which is 41 meters per second.